MCQ 14 is a reaction kinetics question, particularly with the usage of enzyme as a form of biological catalyst. Now you can see that over here we have to assume that the concentration of the enzyme remains to be constant throughout this entire reaction, whereby the concentration of the substrate is actually increasing, which means that it is actually considered to be the variable. Now, the mechanics of how an enzyme actually works, it has to be the entrance of your substrate into its active site that I'm shading over here in pink color. This is the active site of the enzyme. So the number of enzyme definitely will affect the number of availability of active site for your substrate to actually enter, and upon the entrance of your substrate into the active site, we're then looking for a catalysis event happening, and this will eventually lead to the production of your products. And the whole effect here is that we call this middle item here as your enzyme substrate complex. So the greater the tendency to form your enzyme substrate complex is very directly related to the rate of enzymatic reaction. So at a very low amount over here, we can say that we have a large number of active site available, but there's actually considered to be relatively little substrate. So I will say that the whole formation of your enzyme substrate complex, which I'm going to abbreviate as an EX complex, is quite low, and this indicates that you have a very low rate. So as we are scaling upwards here, there is still going to be the same number of active sites. However, with the increasing in the amount of substrate, you can see that the rate is increasing because we are increasing the formation of your enzyme substrate complex. Now, however, at point X, which is what the question is actually asking at this moment, here you can see that the rates have actually plateaued. Now, the reason here is because at a very high amount of substrate, we run into this situation here whereby there are a lot of substrate that is awaiting their turn to enter into the enzyme active site. But since there were limited enzyme active site, we'll say that at this instant here, the enzyme is considered to have its active site fully saturated. So only upon the release of items from the enzyme active site, such as the product that's actually exiting, this allowed the next substrate to enter into the active site of the enzyme to restart the process. So the rate becomes relatively plateau. The only way for us to increase the rate going upwards is that we increase the concentration of enzyme. So this will match the increase of active site with the increase of your substrate. So let's take a look at each of the statements to see what is used to correctly describe the situation when substrate is equal to X, which is considered to be relatively high. The initial rate of reaction is affected by increasing substrate. Now, while this is true, I have to say that this is not correct to explain for part X, because this is going to be helpful to explain the climbing effect as we're increasing substrate at the early stages of this particular setup. And number two, the order of reaction with respect to substrate is 1. Now, this is going to be unlikely because I'll say it's going to be 0 order, because no matter how much you increase your substrate at that particular instant, with the fact that the active site is fully saturated, there is no way that your substrate can help to boost up the reaction. You need to increase your enzyme to match up the substrate. So at part X itself is 0 order already. The increment in your substrate does not have a linear effect on the rate of reaction. So definitely we're looking at selecting part 3, whereby there are no more available active site. The substrate have to queue up for their turn to enter into the active site. And with that, the correct answer for MCQ 14 is going to be the selection of option 3, which in this case is represented with option D.